Bismillahirrahmanirrahim. This question is from February, March 2022, variant 42. Question number 7, topic electricity. Figure 7.1 shows a circuit including 12-volt battery and two identical lamp. Identical lamp means same resistance. So these two lamp have a same resistance. This part number A of this question, the 12-volt battery consists of a cells connected in series. Each cell of the battery has electromotive force 1.5. Determine how many cells are in the battery. So now we have the total voltage, that is 12 volt, and voltage of each cell is also given, that is 1.5. So after division, I will get the answer, and that answer is equal to 8 volt. B part of the circuit, when the switch is closed, the ammeter reading is 2.4 ampere. Mean when this switch is closed, this ammeter gives you the value 2.4 ampere. It means this battery delivers 2.4 ampere current in this circuit, and this current is, we consider the conventional flow, and at this point the current divided into two parts, and this current will be equal in both bulbs. Reason, because the lamps are identical, so both lamps are identical, so current will be divided equally, that is 1.2 ampere in this part and 1.2 ampere in this part. At this point, again, what will happen? The current will have the total value, that is 2.4 ampere. This is just for your knowledge, as well as we need this data in the information in this question also. So calculate the total resistance of the circuit. We need to find out the total resistance of the circuit. Okay. Uh, to find out the total resistance of this part, in the B part, what you need to do, we need the total voltage as well as the total current. Okay, to find out the resistance of the circuit, total resistance of the circuit, I need the voltage as well as the current. So I think I have the both values. R is equal to V divided by I, and V is given, that is 12. This is given 12, and resistance of the circuit, the current in the circuit, that is 2.4. So divided by 2.4, and the answer I will get, that is 5 ohm. This is the total resistance of the circuit. Each lamp has a resistance 3 ohm. Calculate the resistance of the Q. Okay, so this lamp have a resistance 3 ohm. This lamp have a resistance 3 ohm. We have to find out the resistance of the fixed resistor. Okay, see, this is very clear that this part is a combination. Okay, it means this combined part of the resistors is in series with this Q. So if somehow if I find out the resistance of this parallel combination, then that parallel combination will be added with this fixed resistor, and this will be equal to the total resistance of the circuit. So let me write a formula. And for what is the formula? That R total is the total resistance of the circuit, will be equal to RQ plus the R parallel part of the circuit. This RQ is unknown, and RP we can easily find out. What is RP? RP is the parallel portion, resistance of the parallel portion. Both resistors are 3 ohm. It is given in the question, it is given in the information that each lamp have a resistance 3 ohm. So we can find out the combined resistance. So I will use the formula 3 multiplied by 3 plus 3, so 9 divided by 6, it will be equal to 1.5 ohm. Total resistance of the circuit we already have find, that is 5. So here I will put the value 5. RQ is unknown and RP is 1.5. So after rearranging this equation, the resistance of the Q will be equal to 5 minus 1.5. That will be equal to 3.5 ohm. The C part of the circuit on the figure 7.1, draw a symbol for the voltmeter that measure the potential difference across the two lamps. So to find out the drop of the voltage across these two lamps, I need to connect a voltmeter, and that voltmeter will be connected parallel to this combination, and this is the way to connect the voltmeter across the two lamps. When you will do this, you will get 1 mark. The last part of this question, calculate the power supplied to one lamp. So power supply, to find out the power supply, we can use powers is equal to I square into R. You can use power is equal to V square over R. You can use power is equal to I into V. So depending upon the data, you can use any formula in the given list. In this selection, you can use any according to the given data. We have to find out the power supplied to one of the lamp. So let me check. We have a current and resistance. So yes, luckily we have the value of the current, we have the value of resistance. So I think the first formula will be working for us. And this is equal to power is equal to I square into R. Value of I is 1.2 and its square, and R is 3, and calculators gives me the answer 4.3 watt. So 4.3 watt is the answer, is the power that is supplied to the one lamp.